Hey guys, so in this video here, we're going to be talking about graphing absolute value functions. And to start us off, let's just graph something in general, like a linear function, and compare that with how we would typically graph an absolute value function. So with linear function, let's say y equals x, and x is to the first power, and that's how I know it's a linear function or it's a line function. And if you don't remember how do you even come up with a graph, you always start with the table. And so a table allows you to choose what x values you want to plug in. So I'm going to choose, some negative numbers, and maybe 0 is always a good one to plug in, and some positive numbers. I'm not going to make this too complicated. So I'm going to plug a -2 in for x, but then that would mean I would get out a -2 for y. So basically, in this scenario, y is equal to x. So if I plug in -1 for x, y is the exact same value. So all of these are the exact same values. If I were to plug in 0 in for x, y is going to be equal to 0. If I plug in 1, y is going to equal 1. If I plug in 2 for x, y is going to equal 2. So this one's a nice equation because you plug x in, y is the exact same value. So what these are, they're coordinates. And what we'll do is plot these coordinates. So this one's at -2, -2, so right about here. And we have -1, -1, 0, 0, 1, 1, and 2, 2. And so once you have some coordinates, you can connect the dots to make the picture. And so in this case, this is graphing a line because it's a linear equation because x is to the first power. But our question today is to understand, well, if that's what a linear function looks like, what does an absolute value function look like on a graph? And we're going to start with making a table. So again, I'm going to pick some negative numbers. I'm going to pick 0 and some positive numbers to plug in and find the y value. So if I were to plug in a -2 into this absolute value, let's just think about it. A -2 into an absolute value comes out a +2. If I plug in a -1, I get back a +1. If I plug in a 0, I just get back out a 0. If I plug in positive numbers, I just get back the same number. So in this case, all I did was plug in these numbers into the absolute value, got the numbers here. So these are our coordinates. Let's go ahead and start plotting them on our graph. This one here is at -2, 2. So -2 would be right here, but I am going to be going up 2. So right about here. This one is -1, 1. So -1 up 1. And then we have 0, 0, which is the origin. And this guy here is 1, 1, so right here, and 2, 2 again is right there. And if we connect the dots to make our line, we start to notice that we make a V shape. And there's a reason why there is a V shape. Let me actually extend this graph a little bit longer, make it look a little bit prettier. Sorry guys, that was bothering me a little bit, so I'm just going to extend it a little bit further. There we go. So I want us to compare these two graphs here because they are very, very similar. So what you guys might have noticed is that this part of the graph, the right side of the graph, the positive x values, they had the same positive x values, right? So in this case, the graph looks almost identical on the right side of the coordinate. It's the left side of the coordinate that looks very different. And so when you look at the left side, you might notice that this one is swinging down, right? This is in the negative region. And then the absolute value is giving the positive region. Well, let's just try to understand why that's the case. Why would this absolute value be pointing upwards in the positive direction, whereas this guy is pointing downwards in the negative y direction? Well, if we take a look back at understanding what absolute values do, they cause negative numbers to become positive. So that's why this tail right here isn't swinging down. It's going to want to swing up because it doesn't want to be negative. Anytime you put in a negative x value into that absolute value, then it's going to come out a positive y value. And so I want to show you guys that these two equations are essentially identical. The only thing that's different is that absolute values won't give out negative y values. So that's why this one is pointing upwards. Or in this case, if you really think about it, it's like this piece got chopped off and then got reconnected pointing upwards. But what I want you guys to take away from this is that an absolute value makes this V shape. So let's get into all the different shifts that absolute values can have. And what we're going to use is Desmos. Today I'm going to be teaching you how to use Desmos to help you graph equations. But you don't need to use a graphing calculator because I'm going to teach you some quick tips on how you can graph something without a graphing calculator too. But we're going to start us off with using a calculator so we can understand how shifts work. So first off, there is this equation here where I've taken the absolute value. So I've taken the parent function for absolute values, which is the absolute value of x, and I've added some numbers inside of the absolute value, and I've added some numbers outside of it, and I've added some negative numbers in front. And to see what it does to the graph when you are adding things to the equation. So we're going to take a look at what this one would do if I were to put a +2 inside of the absolute value. So I'm going to draw a quick sketch here for us. And we're going to take a look at Desmos. So I'm going to switch my screen here. Give me one sec. There we go. So when we're looking at the home page, if you guys don't know how to get to Desmos, you can type it in the search engine or just go to my homepage and scroll down to the bottom and you'll see a bunch of links here, but you're going to press on the Desmos one for graphing calculator features and it should take you here. And so what you're going to do is type in your equation. So that's the y, and you're going to use your keyboard. As you can see, I'm just typing in a y. And then I'm going to type in equals. But I also want to show you there is a keyboard feature here. If you're not used to using the MacBook keyboard, you can hit this keyboard button and all the special little icons come out. And we need an absolute value sign, so we're going to hit that. And we're going to put in an X and a +2. And so we're going to see what this graph looks like. Now, if I were to just compare this for a sec to the absolute value of just x. So here, the blue line you can see here is the original absolute value of x, okay? So notice that this one starts at the origin, but the red line, which is this equation that has the +2, notice that it doesn't start at the origin. Instead, it's moved 1 to 2 units to the right. Sorry, not the right, the left. So in this case, that's 2 units to the left. So when we have a plus sign on the inside, it's shifting it left. So let's put that in our table here to keep track of all the different types of shift. So this moved to the left to -2, and so that's where it is, but it was still moving upwards. And so in this case, this is going to be left 2 units. That's the shift. So anytime there's a plus sign inside, it shifts left. Now, you can probably guess what this one does. If there's a minus sign on the inside, you're going to be shifting 2 to the right instead. So if there's a minus sign on the inside, you're going to be shifting to the right. So right 2 units. Okay, so let's take a look at what happens if we were to have a plus sign on the outside or a minus sign on the outside. So I'm going to grab my graph here. I'm going to go back to Desmos. All right. And so what I'm going to do is put in so I'm going to get rid of this here. And I am going to put in the +2, and see what it does. So again, this blue line is the original parent function of the absolute value. But when we add a +2, notice that the vertex here is no longer, by the way, the middle point of the absolute value is what we call the vertex. But you can see that the middle point here is no longer at the origin. It is at here at 0, 2. So that means it's shifted up 2 units. So let's record that. See if I can move this aside. There we go. So what we notice is that it moved up 2 units and still was pointing up. So whenever we have a plus sign on the outside, this means up 2 units. And so you can kind of guess that the next one, if you had a -2 on the outside, this is going to be the opposite direction. So it's going to be scooting down. So scooting down to -2, and then it'd still point in the same direction. So this one would be down 2 units. And last but not least, I thought I mentioned this one here. Anytime you have a negative in front of the x, what happens is it causes the equation to flip. So notice that this is pointing upwards, right? So if you had a negative in front, that means it's going to be pointing, probably you guys can guess it, it's going to be pointing downwards. So this one doesn't have any right or left shift. As you can see, there's nothing inside of the absolute value or outside. So it's going to be still at the origin, but because of that minus sign, it's going to be pointing down. So I'll just say flips upside down. So let's go ahead and summarize all of the shifts that we've learned. It basically says that anytime you have a positive sign on the inside, you should be shifting left. Negative on the inside, you're going to be shifting right. So to kind of bring things together here, let me move this down a little bit. There we go. So if this inside here is a negative, you're going to be moving right. If it's a positive, you're going to be moving left. If the outside is a positive, you're going to move moving up. If it's a negative, you're going to be moving down. So that's talking about the number that's outside. So positive up, negative down. And I just put an H and a K here, but H and K are just numbers, or any numbers that would be sitting there typically. And then for if you have a negative sign in front, what that is doing is it causes the equation to flip upside down. But more importantly, anytime you have a number in front of your x, that represents the slope. So a number in front of x in these absolute value equation represents the slope. But more importantly, what I've mentioned before is that you are shifting essentially the vertex. The vertex is the middle piece of the absolute value, or the V shape. So this is the vertex, this is the vertex, this is the vertex, this is the vertex, this is the vertex. So the middle part is the vertex of your absolute value. And usually you can tell the value of the absolute value using the numbers that are from the equation, specifically H and K. And so vertexes are a point on the graph, but so they are a coordinate point essentially. In the next video, I'll show you how to graph absolute value functions using the shifts, and then also finding the vertex and telling whether it's a max or min. But that's it, guys.